All right, so we are going to look at function tables now. So what a function table is it's where you take a bunch of those kind of problems like what we did, but you use the same function and you put in different values for it. And it's kind of like similar to what you did when you were graphing, right? You want to find a bunch of different values so you can get a sense of what this thing looks like on the graph. The difference with function table is we don't bother with graphing it. All right, so when you're picking values for a function table, I think the big thing with this is just don't pick anything silly. Don't pick giant numbers because it just doesn't make sense. Pick numbers, maybe anywhere from -20 to +20. And you always want to make sure you're picking at least one negative so you can kind of see how this thing acts when you put a negative into it. All right, so I'm going to start, and I'm going to pick 8. All right, and I just pick the first number that came to my mind. So 8 is going to be my x. So then in the next column, where you see x plus 7, I'm going to rewrite that as 8 plus 7. And I'm going to try and get in the habit right away of always putting that in parentheses because it gives you a visual reminder that that is what you are substituting. Okay, so 8 plus 7 is 15. That was easy. All right, let's do 3. So if I do that, you put 3 in. Okay, and then 3 plus 7 is 10. Now let's see, let's do 0. I like doing 0. I think 0 is kind of fun. 0 plus 7 is 7. And then let's pick a negative number. Let's do -4. So if you put -4 in and you add it to 7, well, that's the same as 7 minus 4. So it's going to give me 3. And you can see that if I were to put another value in that was bigger than -7, or smaller than -7, pardon me, like maybe -11, then you would get yourself to a point where you start getting some negative values. Okay? So that's kind of what's going on with this function table. All right? These are pretty straightforward, not complicated. You just pick some numbers and put them in. Most of the problems you do are going to ask you to pick 4 numbers. All right, so choose 4 values for x to make a function table for this function. State the domain and range of the function. Okay, so let's go back to the last one. So the domain and range, when you talk about domain, you're talking about what x values did I put in. So the x values, you always go smallest to greatest. So I would say, well, I put in -11, -4, 0, 3, and 8. And I put it in this set notation, which is like these brackets. All right, and then for range, it's the same thing. You use the brackets. And then the range, you just say, well, what are the values you got out? Well, I got all anywhere from -4 up to 15. So -4, 3, 7, 10, 15. So that is where we are at for domain and range with these. So let's look at this next one here. So let's just pick some values and see what happens. Let's put 10 in. So if I put 10 in, this thing lets me. 2 times 10 plus 8. Well, 2 times 10, this is 20. And then you add 8, you get 28. All right, so let's do 2 now and see what happens. Well, 2 times 2, so that's 4 plus 8, so that's 12. All right, that's good. I think I'm going to skip 0 this time, and I'm going to go to -3. So if I do -3, I go 2 times -3 plus 8. Well, 2 times -3 is -6. And -6 plus 8 is still a positive number. That's 2. And then if I go bigger than that, and I go to -10, you have 2 times -10 plus 8. So it's -20 plus 8. So to figure out what -20 plus 8 is, you just do 20 minus 8, which is 12. And then you take the sign of the number with the larger absolute value. So I'm going to keep this sign, so it's going to be negative. So -12. All right, and you can kind of get a sense of how this works. And then your domain is what x values did you use? Well, I went from -10 up to 10. And so you go smallest to greatest. So -10, -3, 2, and 10. Then your range is just your y values. And again, go smallest to greatest. All right, so start -12, 2, 12, and 28. And this is just saying these are the values I put in, and these are the values that came out. And it doesn't necessarily mean that they correspond to each other, but it means that those are the numbers that you got out. All right, let's try one more. So pick our 4 values. Well, let's start again. Let's do 10. All right, so if I put 10 in to this one kind of behaves a little differently than the other ones we've done. So I'm going to do my multiplication first. I'm going to do my 3 times 10, and that's negative 30 because you're subtracting it. So it's 7 minus 30, which is the same as 30 minus 7, right? You get 23. And it's going to be negative because that 30, it's 7 minus 30. That 30 is negative. It has a larger absolute value, so we keep that sign. You always keep the sign of the number that has the larger absolute value. All right, so let's try 0. See what happens. 7 minus 3 times 0. All right, well, that's just, this becomes 0, and so it's just 7. That was interesting. All right, well, let's do a negative number. Let's do negative 3. So if I go 7 minus 3 times negative 3, well, 3 times negative 3 is negative 9, but you have 7 minus a minus 9. So this whole thing becomes positive, and you get 16. All right, so you can see kind of what's going on. They start negative, and they go up. As your x values get smaller, your y values get larger. That's kind of cool. So if I put negative 10 in, I have 7 minus 3 times negative 10. This is going to give me positive 30 because there's 2 negatives. So 7 plus 30 is 37. So again, domain, it's just your x values from least to greatest. So negative 10, negative 3, 0, and 10. And then your range, smallest to greatest, negative 23, 7, 16, 37. And now you can see what I was talking about, how they don't necessarily correspond to each other. Because negative 23 goes with this 10, 7 goes with 0, and it kind of goes like that. But when you're writing them in this notation, you always just go least to greatest, and you don't worry about them matching up with each other. All right? Okay, that's kind of that's the skinny. That's how this works. Good luck with these, and stick with it, man.